module, you will learn about operations on vectors. Operations on scalars are the same as in elementary mathematics and algebra, whereas operations on vectors obey the triangle law and parallelogram law of addition. You will learn various operations on vectors one by one in detail. First, let's start with multiplication of a vector with a real number. When you multiply a vector p with a positive number lambda, you get a vector whose magnitude is changed by the factor lambda. The direction remains the same as that of p. Mathematically, it is expressed as mod of lambda p is equal to lambda into mod p. For example, when p is multiplied by 4, the resultant vector is 4p, whose magnitude is 4 times that of mod p. On the other hand, when you multiply a vector p with a negative number lambda, you get vector minus lambda p, whose direction is opposite to the direction of p, and its magnitude is minus lambda times that of mod p. For example, when you multiply p with minus 3, you will get vector minus 3p, whose magnitude is 3 times mod p and direction opposite to the direction of p. The dimensions of lambda p is the product of the dimensions of lambda and p. Next, you will learn about addition of vectors by the graphical method. In the graphical method of vector addition, either the triangle law of addition or the parallelogram law of addition is used. Now let us add two vectors by the triangle law of addition. Consider two vectors p and q lying in one plane. Draw a line AB parallel to P. The length of AB is equal to the length of P. Display an arrowhead at B. A is known as the tail of P and B is known as the head of P. Then draw a line BC parallel to Q and equal in length to Q. Display an arrowhead at C. B is the tail of Q and C is the head of Q. Note that the tail of the second vector always coincides with the head of the first vector. Now join AC. Display an arrowhead at C on line AC. AC is vector R, obtained by adding P and Q. Similarly, draw a line DE parallel to Q. The length of the line DE is equal to the length of Q. Display an arrowhead at E. Then draw line EF parallel to P and equal to the length of P. Put an arrowhead at F. The tail of P coincides with the head of Q. Now join DF. Display an arrowhead at F on the line DF. DF is vector R obtained by adding Q and P. Here, vector R obtained by adding P and Q is the same as obtained by adding Q and P. This vector addition is the commutative property of vectors. Vectors also obey the associative law of addition. To understand this, consider three vectors A, B and C lying in one plane. Add A and B to get D. Then add D and C to get R, which is the final result. Similarly, add B and C to get E. Then add A and E to get R, which is the final result. Here, A plus B plus C is equal to R in every case. This proves that vectors obey the associative law of addition. What happens when you add two vectors that are equal in magnitude but opposite in direction? It results in a vector possessing zero magnitude and is called a null vector or a zero vector. In case of a null vector, you cannot specify direction. Various operations with a null vector are A plus 0 is equal to A. Lambda 0 is equal to 0. And 0A is equal to 0. Let's discuss the physical meaning of a null vector. Consider a body is occupying position P with its position vector R at time t. From time t to t dash, it moves from position P to P dash. Its position vector at time t dash is R dash. From time t dash to t double dash, it moves back from position P dash to P. The displacement of the body during the time interval t to t double dash is 0, as the body has returned to its initial position. Its displacement is thus represented by a null vector, which is just a point with zero magnitude and without any arrow. Now let us discuss the parallelogram method for the addition of vectors. Consider vectors A and B, which are to be added. Redraw the two vectors with their tails coinciding at a common origin O. Complete the parallelogram by drawing parallel lines. Then, draw a diagonal passing through O. At the end of this diagonal, display an arrowhead. The diagonal represents the resultant vector R. After addition, you will now learn about the subtraction of vectors. Direct subtraction of vectors is a little confusing. To avoid this confusion, you must use the concept of addition of vectors after reversing the direction of the second vector. Vector minus B is added to vector A to get R. This method makes the subtraction of vectors easy. You have now reached the end of this module. In this module, you learned that in the graphical method of vector addition, either the triangle law of addition or the parallelogram law of addition is used. In vector addition, the tail of the second vector always coincides with the head of the first vector. Vectors obey the commutative and associative law of addition. To subtract two vectors, you must use the concept of addition of vectors after reversing the direction of the second vector.